Hello friends, so in today's video we will continue our discussion related to SD-WAN, that is software defined wired area network. So in previous video we had seen some basic details related to SD-WAN. So we had seen what is SD-WAN, then basically SD-WAN benefits. After that we had seen SD-WAN uses and functions. We had seen history and evolution of SD-WAN, then we had seen SD-WAN service components. Now in this video we will be seeing further topic like how does an SD-WAN works. So basically SD-WAN, as we all know, it is a software defined wide area network. So basically there is a software component involved in the networking. So what it does is basically it will be creating encrypted tunnels or the overlay between the multiple sites, and each site will be equipped with SD-WAN device. Now if we go to the previous diagram, we can see there are two sites which are shown in the diagram, and each site is having SD-WAN edge device, and here other site is also having SD-WAN edge device. Now these devices are connected to each other over two types of network. One of the network is internet and other network is MPLS VPN, and these two devices are connected to SD-WAN controller. Now this line is shown as dotted line. That means there is not a physical connection between a direct physical connection between SD-WAN edge device and SD-WAN controller. However, there is a connection via internet to the controller devices basically. So now let's go to the next step. So what happens is whenever these SD-WAN edge devices are connected to the local networks, these devices will automatically download custom defined configurations and traffic policies. And after that, these devices will establish tunnels with one another, or if there are other point of presence, that is POP locations, depending on the architecture. So what will happen is whenever these SD-WAN edge devices get an internet connection, those will be downloading the predefined configurations and policies which will be maintained by the SD-WAN controller, or those can be downloaded from any repository which are being referred by this MPLS or SD-WAN edge devices. Now what will happen is routing and traffic control is managed by the SD-WAN. So the software component, what it does is it will manage the routing of the traffic and control, and basically the traffic control will also be done by the SD-WAN. So how the traffic flow will happen, what kind of data will take which kind of path, whether it will go via internet path or whether it will go via MPLS VPN, that will be decided by the SD-WAN devices. Now what will happen is whatever is the outbound traffic, that will be routed along the optimum path based on the application policies and real-time traffic conditions. So suppose for example there is a certain type of data, for example if it is a voice over IP data, and by default if it is configured to send it over MPLS VPN to the destinations, then that decision will be taken by SD-WAN. However, due to some congestion in the network, if MPLS is not responding as per expectation, then SD-WAN edge device can take a decision to send that traffic over a internet direct internet path via overlay tunnel. So that decision is taken by the SD-WAN. That decision is taken by based on the predefined policies and real-time network conditions. Now also another scenario is, suppose if one of the last mile connection fails, then SD-WAN device will automatically fail over to the alternate connection, and it will use the predefined configurations and the policies to manage the traffic load. So what will happen is, for example, say if there is certain issue in the MPLS link which is present between these two sites, then whatever traffic which was configured to go via this MPLS VPN, that traffic will be rerouted via the internet connection overlay tunnel. So if the MPLS VPN link breaks down due to some issue, then it will not happen, like it will not be stopping the traffic from going. This SD-WAN device is intelligent enough to route that same traffic over the alternate failback link. That is another benefit of the SD-WAN. Now Such kind of a policy based management is very essential in the functionality of SD-WAN, because that's where the software component will come in, and it can be basically scheduled, or it can be configured as per the requirement. Now, the policy will be used to determine the dynamic path selection, and it will steer the traffic based on the level of priority, or we can call it as a quality of service basically. So what will happen is, not every traffic is treated in the same way. So there are categories of the traffic which will be having higher priority than other types of traffic. So suppose if there is a voice traffic which needs to be transferred. Now voice is a real time traffic, right? So it has to be given highest priority, right? Because the voice should be in the continuation. Suppose if two people are talking on the phone line, then it has to be as much as real as possible. It should not feel like, suppose one person says a word, and if it has a very large delay to reach to other person, then it won't serve a purpose, right? Because then it won't be a kind of a real time communication in the voice format. So voice will be given a highest priority. Suppose if somebody is sending a data, basically, then that data is not a real time traffic, right? So if even if some packets reach a little late, then also, unless the entire download or entire transfer is complete, the picture or the data will not be accessed by, or will not be used by the user, right? So data can be taken on a lower priority. So such kind of decision can be taken via the SD-WAN device, because it is an intelligent device, and it can do the dynamic path selection, and it can do the level of priority, decide the level of priority basically based on the quality of service class. So now there can be multiple policies which can be created to meet certain specific business needs, right? Such as we can grant a certain type of transmission packet. Again, like example is a voice over IP, and other interactive services to improve performance. Again, other example is kind of a video call which we do, right? So it's very important that there has to be kind of a feeling that the communication is happening on a real time. Sometimes we say, right, there's a delay in the network, right? Then the experience is not good, because some person talks, and then it takes a very it takes longer duration to reach to the next person, and then the video gets stuck, right? So these kind of issues can be avoided by using the priority based traffic transfer. Now that was the basic functionality of SD-WAN. Here also we are having another diagram which can show us the some of the components of SD-WAN. So we have a branch office, then we have SD-WAN routers, which is a SD-WAN device, and SD-WAN device is connected via multiple links. So we can see there is a DSL link, then there is a fiber link, there is a LTE which can be wireless, and it reaches to the public internet. After that, again there are two kind of link. One is DSL and fiber. It connects to the SD-WAN routers, and it reaches to the main office. And we can see there is a SD-WAN controller device which is in connection with SD-WAN routers, and it is basically controlling these devices configurations. So if I want to push any configuration, I am not needed to go to individual SD-WAN routers. Administrator can directly connect to SD-WAN controller, and he can push all the configurations from the SD-WAN controller device. Right now, there is another technology which is known as the MPLS, which is older than SD-WAN. So MPLS is multi-protocol label switching, and that is also widely used technology. So what is basically, if we compare MPLS to SD-WAN, there are certain points which we can come to know. Like SD-WAN, basically it's evolved from MPLS technology, and MPLS is basically, it has powered the private connectivity for more than 2 decades. So whatever large organizations are there, right, for secure data transfer, they rely on MPLS, because MPLS is a very secure and fast data transfer technology. Now we can, in many ways, SD-WAN is kind of a software abstraction of the MPLS technology, and that is applicable to wider scenarios. Because what happens in MPLS is, there are packets which actually go to the devices, which actually go via routers. All the policies are predefined or hardware embedded, and the decision of the data transfer is taken into the traffic plane, so it doesn't go to the data plane of the devices basically. So SD-WAN is little bit different from that, and SD-WAN also brings the secure and private connectivity, and that is agnostic to all kind of links and providers which are cloud aware. Because SD-WAN works via as a software abstraction, it is easier to work with the cloud technologies using SD-WAN. Now MPLS was able to handle failure scenarios with backup links, and SD-WAN handles these scenarios based on the real-time traffic steering based on a centralized policy. So in MPLS there could be limited number of links which can be physically present, and if one link fail, the traffic will be passed using other physical link. And in SD-WAN what happens is there are multiple links available, and the decision of traffic rerouting is taken by the SD-WAN routers or SD-WAN edge devices based on the centralized policy. So in this way it works as a backup, or it handles the failure scenarios. Now also, since SD-WAN unifies the entire WAN backup, because SD-WAN controllers will have connectivity with all the SD-WAN routers or SD-WAN edge devices. So SD-WAN controller will have visibility of all the basically whatever analytics which are happening over the network. If there is a congestion, if there are any faults which are happening, right? So it can have the comprehensive analytics across the global network. Now this wasn't possible before because the infrastructure was separated and the policies were different and the network was widespread. So the unified view was not available, but using SD-WAN that can be achieved. Now this was the additional information related to SD-WAN working. So if you like this video, please subscribe to my channel. I will put more such videos. So thank you for watching my video. Bye.